Well, it looks like we're all in the room, so we may as well get started. I know that we're just coming out of the main presentation as well. So welcome everybody here for the track. It's about a 2-hour-long track. We've got 4 speakers going over various aspects about microservices. And so without any further ado, I'd like to introduce David Chase from Ping, who is coming up to talk about SPAs, microservices, and identity. So David, the floor is yours.
Good morning. So I've been asked, well, I'm speaking about SPAs, microservices, and identity. Just a little bit about me. I've been in the identity industry for over a decade. I've done a lot of the different things from professional services to sales to architecture and labs. So I've seen a lot of these different patterns, and I thought this was an important one because we're seeing a lot of questions around it just with ourselves. And so I thought I'd come share this information with you. If you have any burning questions, I'll be happy to answer them at the end. We'll have a microphone that we'll bring around that'll make it a little easier to do. So, without any further ado, really, what is a SPA? How many people are dealing with SPAs today, working on them? Okay, so quite a few people, wow, more than I would have anticipated. So this kind of changes the whole HTML paradigm that we're used to with our applications, right? SPA is literally a single page, so you have one HTML file that you're downloading, and then as the user interacts with it, it uses AJAX to update the elements on the page. And that will also generally making API calls on the back end. There's a lot of frameworks for this that make it easy to develop, right? So you have JavaScript and things like AngularJS, Ember, React, UI libraries that are available. So it's helping to speed development over what we've seen with the traditional HTML applications. Why are we doing them? Well, if you're building APIs, you don't need to build now an HTML layer in front of your API, right? You have the client do that. Having planning for more than one client makes your life easier. If a customer or another department wants to use your service, you don't have to recreate your entire thing and embed it in somebody else's application. You literally just say, hey, call my API, and you walk away, right? You have a contract. Of course, you make the mistake of updating that contract. That's a completely different story, right? Frameworks make the UI easier, right? You don't have to develop everything from scratch. If you think about things like Bootstrap and all these other CSS libraries, they do a lot of this work for you. You can offload some of the server-side work, so if you need to tumble lists around and filter them, sometimes the client can do that for you, depending on how big they are. And then, of course, if you're thinking mobile first, small API request responses can actually be a huge improvement over reloading an entire page, right? You don't want to be taking up people's data with these entire page reloads because they deleted or added a single element to a list. All right, so how's the security paradigm different? Well, most of us are using WAM products, yes. We've got WAMs in front of our HTML pages today, and we think about this, we simply drop either a WAM server as a proxy or as an agent in front of every request and response. So I load up the page, it checks my authn, authz, it gives me an HTML response. I add an attendee, hit submit, does a form post, creates a new HTML page, right? The entire page reloads. Well, it's really easy to see here where you can drop in WAM application in front of the traditional web server. With a SPA, it's completely different. You have this initial request, which downloads the HTML page. And then after that, there are no more HTML requests. You're not going to time out on a session. You're not going to time out on a cookie because literally it's never talking to that application server from over for HTML again. There are AJAX or API calls, which are getting JSON responses. So if you were to try and layer this in, the WAM works. You have every request being authorized. Your WAM can even mitigate some of the data that's coming back, right, as it rebuilds the pages and the HTML responses. If you try to do this with a SPA, it doesn't really work, right? You think about this, you have initial request that you're going to make with some sort of HTML cookie, and then you need to flip that over now for your API calls to access tokens, hopefully, right? Now you could do that, and I've seen some people actually do this in different ways, but it doesn't really map up in a one-to-one way. A lot of the reason being is, well, if I try to use a cookie at my WAM to get an access token, what if I do have something that's actually an API client and not that web page? So then I end up having these 2 different services, or I have these 2 different token generator, authorization servers, and so the model starts to fall apart there. It's great if you only have one client, but I don't think you can really restrict yourself to saying I'm only ever going to get API calls from my client. If you are, I think you should expand your view and think that, hey, the best form of stickiness or the best way to integrate with my customers is then have them calling my APIs directly and not expect that I'm the only person in the world who's ever going to build a UI. So this model kind of breaks down. Now if you think, all right, well, let's take the WAM out of that initial request and think about, okay, it's just a static asset, can be really hosted anywhere in the world, right, CDN. We download it into the client, and hey, I don't know who you are, right? It starts up, I don't know who you are. Well, we have a pattern for that for authentication requests, right? Let's talk about using an OIDC provider or a authorization server to get an access token. Now, whether it's OIDC or just plain OAuth, that'll depend whether it's in your domain or another domain, right? If it's all in one domain and you own both the client and the authorization server, implicit flow of OAuth is fine for a SPA. If it's cross-domain and you're having customers log in with Facebook, you're more of a customer-facing app, then you probably want to do an OIDC flow. But either way, you now have your access token, you know who the user is, and they start making requests to your API via your gateway, where you can possibly enforce token checking, other types of permissions, or you might simply do that at the API level, depending on exactly what your architecture is. So what's this look like? Well, it looks like a lot more like a mobile app than a web app, doesn't it? Right? All my code's running in my client. Client handles the OIDC authentication itself. I don't have to be in front of that dance, and then it just makes API calls. Right? So if you think about it, well, a SPA is more mobile or more of a client than a web app. And the other thing to keep in mind is because all of your code is running in the client, you can't protect any of it. Right? So no secrets in your client code. Right? So that's why I would suggest implicit flow. Because they can literally view source and see everything that you have, right? So any secrets are up for grabs, even easier than they are with mobile apps. So it's my recommendation for a SPA. If there's any, I'll move on. We'll come up with questions at the end, so please hang on to them. I'm going to move into talk about a little bit about microservices. What's a microservice? Well, it's a service that literally does one job. We think about like a bounded context, or it'll fit inside your head, right? So if you think your entire application for anything doesn't fit inside your head. I compare these really often to like Java classes, right? Where would you put the bounds on that? Well, my favorite answer is it depends. You can either put as much functionality in there as you want, or as little. It's really what's going to make sense for your application. If it has 10 parts, am I going to reuse any of those parts separately? Well, that might be a good place to draw another microservice. If it isn't, then, well, you might want to just keep it all bundled together if it makes sense to you. But it probably owns all of its own data. Denormalization is a great thing when you look at microservices because updating one service shouldn't require updates or modifications to another service. So if you think about your data schemas, changing between services, if no dependencies, no updates. Loosely coupled group of them will help create your application. You can think that, hey, I could have a OAuth service, I could have a SAML service, I could have a sponsor service, I could have an attendee service, users, groups, all separately, and I can couple them together any way I want. Nice thing is, a lot of times that the complex logic that we typically build into our applications then gets moved to the client rather than into our services, simplifying our code tremendously. So, if anyone is, I certainly wouldn't want to suggest that monoliths are bad. They're great. I work with them every day. I love them. I'm from Ping Identity, so we have several great monoliths, but there's just different uses, right? If you're going to deploy software on-prem, monolith's probably the way to go, right? I don't want to try and deliver 40 loosely coupled microservices with their own data structures on premises. It's not really a good idea, right? Think of that. Whereas a monolith in the cloud, well, there's scalability problems, right? How do I increase my OAuth capacity, but not also have to bear the burden of moving all the SAML code at the same time? How do I update a database schema when it's one giant relational database that all works together, right? So there's these, microservices are generally more for a cloud mentality. Some of the advantages we can get, though, small teams. You can have 2 or 3 guys build a microservice. The hope is that it's less than a week's work, right? You just go out and you rip them out. Parallel development. If I'm doing OAuth and SAML functionality at the same time, I don't necessarily, if there's no dependencies between them, then one can run off and do what it needs, and if the other team gets blocked, that's okay. It doesn't affect my entire schedule. Iterate quickly, right? Very agile. The idea is you build it, deploy it, test it, tear it down, do it again, tear it down, do it again, tear it down, do it again. So hopefully you can build faster, find your bugs faster, do a lot of tons and tons of testing on these things. Linear scalability, as I mentioned, so that you don't necessarily have to redeploy the entire application. You can just add more services, so linearly, and you don't really ever bump into that vertical scalability, which can also incur a lot of costs if you have large applications requiring lots of RAM. You think about those large instances or extra large instances on Amazon, they can get pretty expensive. So our typical monolithic architecture looks something like this. You have a client that's talking to a UI layer. Client maybe almost always today is a browser. We're generating HTML that it's reading, submitting form posts to. We have information systems in the back end, and then somewhere at the back there's probably an MVC architecture where we write everything to a database, right? So, or a file system. So you spin it all up and it just works. You need to update it, you just update the whole thing, right? You need more of it, you just deploy more of the whole thing. A microservices architecture that works with a SPA will look a lot more like this, right? So you're gonna have a client. I really wanted to draw like 30 client boxes because that's my mentality. I want to see a whole bunch of people using my APIs, and only one of them using my HTML. But then you have an API gateway, probably sitting at the edge, protecting this, enforcing OAuth, so that the individual applications, I still suspect that you'll want to protect them, revalidate that token in each one. You'll notice there's a line between them, so there may be direct communications between your services. And then, of course, they each own their own data. So what do we do as far as protecting these? Well, I think OAuth is the right choice, right? OAuth 2.0. I would really recommend that you look like JOT tokens versus reference tokens. You think about if I had every one of these validating a token versus a authorization endpoint, well, that's going to be a lot of hits on that authorization point. So freeing them up to do introspection and validate the endpoint themselves is going to take a lot of load off that authorization server. Obviously, some great things we saw, people talk about recently, like token binding. Well, that's really cool. If I can bind my client to that token, that's great. But what if, once I get past that API gateway, well, now it's the API gateway is the client. So before you go to token binding, you're going to have to think about REST STS, right? I need to exchange that token. My gateway now needs to be an OAuth client. I need to take the existing token, get a token on behalf of that end user or that application, and then I can play that inside. And furthermore, as it goes down the stream, you're going to see the same process where those individual microservices need to get their own tokens. So you think client credentials flows, right? Mutual TLS, getting their own tokens so that they can act on their behalf. Of course, you'll want to have an auditing system that keeps track of all these changes of who does what. So while microservices in a lot of ways will solve many of your problems, it's certainly not going to solve all of your problems. It's going to introduce a whole new set of technologies you need to think about and solve. Like, how do I inject secrets into these microservices, right? We don't want a properties file with code in the cloud. So how do I inject secrets? How do they get their access tokens? Is it just a key? How do I put that key in there? How do I rotate these keys? How do I protect these communications? So if the delivery service calls the order service directly or vice versa, how do I know that it's not someone spinning up a malicious microservice and injecting bad code? So these are all things that you have to consider that go above and beyond authorizations, but overall securing your entire app. One practice I would assume is that there are no safe areas, no DMZs. Bad stuff can come from anywhere. So rather than, now the other thing you'll hear from probably your application developers is that there's going to be latency when these two applications talk to each other, right? I'm the client, I'm hitting the HTML, it makes an API call, that makes a call to the ordering service, that ordering service makes a call to the delivery service, and I have to wait. Now, that's fine for this two services, but if you think about, like, I'm going to get maybe 5 calls, 10 calls, suddenly that all breaks down, right? You can't really, you don't want to have that many API calls layered together. So you probably think about something that's a little bit more efficient in your model. So you could have an event bus between them, right? The event bus allows me to say, well, gee, I'm going to have 15 things listening to every time I create an order or I create an attendee. I need to send them an email notification. I need to figure out their payment. I have to audit who logged in, who paid, et cetera, all this information. Well, I don't want to have that to be direct communication between everything. So you inject an event bus in between. But you certainly don't want to be publishing a bearer token on an event bus, right? Because it's a bearer token, and I can just pick that up right off the bus and reuse it myself. So how do I protect all these things that are going, how do I authorize all the things that are going on the event bus? And then additionally, how do I know that the person who put them on the event bus had permission to do so when I pull it off the event bus, right? So I've got a listener, I'm gonna send a, I'm gonna actually process some payment. They've gotta know for certain that these people were authorized to put it on and also to take it off. You might have PII in an event for a create user. So I need to protect both ends of this. I can't just simply say, oh, it's on the bus, it's good to go. And then of course you're gonna have people say, well, you need to encrypt all this PII while it's at rest. So lots of things to think about is that sort of. So one of the things we're thinking about here is only authorized producers can create an event, only authorized consumers can read an event, and you have to be able to change these keys. One of the things that we're looking at using ourselves is JWEs. Solves a lot of this if you can control the key distribution by injecting them into the individual microservices. You can simply say, well, I have a producer key and a consumer key. Only people that have the producer key are going to be able to create a message that the listeners for that topic are going to be able to decrypt correctly and process. So you put it on both sides, and then of course only people who have the correct consumer key can read that value and do what they're doing downstream. So I can protect who's getting the PII as well. It's not a perfect model, but it has a lot of advantages over simply publishing something to a bus. Additionally, a lot of the off-the-shelf buses have their own identity systems built in. They're more for individual users rather than clients or services. And so you're having to integrate that with your own environment. So it can be a little bit more challenging. But overall, trying to stick with a standards-based architecture, this one's pretty close to what I need. So I'll go ahead and open up for any questions. Mr. Skyberg.
So I'm thinking, trying to think about how, I'm trying to think about how on the slide that had the API gateway, right, how common identity infrastructure labels lay onto that and what labels you would put on the API gateway. It feels like, at first I thought, well, that's a service provider that's doing token exchange weight. That feels more like an identity provider providing federations. I'm not sure how you think about that. Do you have any thoughts on that?
Yeah, so for us, that's actually several products that are rolled into one that I just kind of label an API gateway, right? So I have my authorization server. First, I have to be able to issue that client a token. So mutual TLS, that's going to exchange a token, or I'm sorry, with the client, it's going to be a implicit flow, so that client gets a access token. Then when they actually make that request to the API gateway, for us, that's actually a identity-aware API gateway, ping access. There are many products that you can use in this regard, but simply it's something that's going to validate the token, apply some rules as far as, hey, do they have the right scopes to make this call? So if you think of, I hate to say service-oriented architecture, I want to stop any unauthorized calls as close to the edge as possible. So I might say if you're doing a post to the user's endpoint, you must have the create user scope, right? Just basic sanity there. Other things that must go in there when you think about a microservices architecture, microservices themselves are ephemeral. So they spin up and they go away and they're replaced someplace else magically. So how does your gateway know where they are now? So you're thinking about discovery services, such as something like as console and Linkerd, so that you can route the traffic effectively from your gateway layer to these things that are constantly changing and moving around. So yeah, it's kind of a lot of functionality piled into one little box. Great question, thank you.
Yeah, you mentioned use of JOT format for access tokens to reduce callbacks to the AS. Is that a standardized function in the industry, or is that just scope to any given provider's implementation?
I think, so OAuth is awesome in that way that they haven't really defined the format of a token, but a JOT itself is well defined, and I think it's well supported, so you find it in many products. It makes use of the Java Web Key URL to locate the key. So I think it is well standardized enough that you could probably find it in many implementations of OAuth. OIDC requires that functionality. It's basic part of the, of that spec.
So it would work, is what you're saying?
Yes.
Interoperability should work.
Yes.
Just one comment, sorry.
That's fine.
To that JOT thing. We use JOTs, and the reason we do that is for statelessness. We want all microservices to be stateless. And so if you give them all the metadata about the user, they don't have to go anywhere else. They have all of the metadata they need to do authorization and being able to control access. But I have a question for you about implicit flow.
Yes.
Given all the vulnerabilities and problems with implicit flow, what we've adopted to do is kind of a hybrid between auth code and implicit. So it's an auth code flow, but it doesn't have a secret. So it's a single page. They get the auth code, and then they exchange the auth code for an access token. But there's no secret. The reason we did that is to get the long-lived access token out of the URL, out of the fragment. Any thoughts on that? Have you seen that pattern before?
My concern with that would be that, if they're able to steal the long-lived access token, I'd be more concerned about in some applications, they may be able to intercept that, the access code that's returned. And if I can, if you're using a custom URL scheme in a mobile app, squatting is kind of a known issue there. So if I steal that, that access code, and I'm able to decompile your code like you can with, in JavaScript or even mobile apps, I can get, the ID of the client. And so even though there's no secret, I really haven't improved anything. The threats may still be there, but I can understand. I would probably look at something more like Pixie in those type of instances, to where I could say, hey, I can go ahead and have a client ID in secret, but you can only steal one token at a time because you have to intercept this entire flow, right? And so even though there's a client ID in secret, the secret's almost meaningless because you're negotiating one at runtime over HTTPS. So, and it would be standards-based. So it's something to consider, but great question. And thank you for the comment about statelessness, because REST kind of infers that, right? You don't want state anywhere really in the system other than the client, because all your requests should be item potent as far as gets and deletes, or gets and puts, and basically not trying to store states or other information in JSON objects that are then passed back, because that just makes things too complicated. Handle that client side. Thank you.
Hi. In our traditional web server-based apps, we had security requirements like session times out after 15 minutes, or somebody clicks log out and that session cookie is invalid, can't be used anymore. So now we're moving to SPAs, and our security team wants to keep those requirements, but that seems to be incompatible with this notion of having JOT tokens that aren't hit against the authorization server. What I'm saying, are those unreasonable requirements to have for SPAs? I would love to be able to tell them we just can't do that anymore.
I would agree with your security team. I still want those things. However, your SPA isn't going to do all of them, right? So for me, my authorization server is where I'm storing my session, right? So I can still give short-lived access tokens, and if invisibly, you're going to want to refresh those with your authorization server so as not to disrupt the user experience on every API request. So think about invisible iframes to update that access token. Use the existing cookie that you got from your authorization server to get a new access token, and play that. Now, as far as logout, we do have the ability to kill that session cookie, and your authorization server may support a set of revoked JOTs, so that they can kill it early. However, if you're doing short-lived enough JOTs, the logout functionality, probably doing single logout with your authorization server, should be close enough to real time to mitigate the need to actually worry about trying to invalidate that individual token.
Got time for one more question, Rick.
You talked about token binding at the client level, and then it having incompatibilities when an API gateway comes into place. Can you expand a bit on that, on how you would approach that when we have token binding on the browser and we have an API gateway that does token translation to talk to microservices?
I'm sorry, I couldn't make that all out.
Sorry, so you were talking about token binding that happens at the browser.
Yes.
And then incompatibilities when an API gateway comes in place and does the delegation function using probably the token exchange.
Yes.
How would I mitigate that problem?
Well, so if you bind the token to the browser is the only one that can use it. And basically, you're only going to be good from the browser to the API gateway. So now the API gateway needs to be able to do some function on its own to go get its own token to play that. So really that's kind of covered by the REST STS, right? So you figure the API gateway now will have the requirement of also being an OAuth client that can get a token and use a token. And then your microservices will probably have the same issue. If you have any kind of chaining down the line, those will have to get a token on behalf of that original token. It gets a little messy, but I think it's worth the work for the security outcome.
Well, thank you all for coming. Unfortunately, we have to cut it short, and there was about 8 more hands that went up in that. So you'll be around for the afternoon, and absolutely, I would carry on the discussion. But thank you all for coming, and we should start the next one in about 10 minutes.